Shifting gears to AI, Peter was here earlier and he was talking about how so far the only company to really make money off AI is NVIDIA with the chips. Do you have a sense yet of where you think the big applications will be from AI? Is it going to be in enabling self-driving? Is it going to be enabling robots? Is it transforming industries? I mean, it's still, I think, early in terms of where the big business impact is going to be. Do you have a sense yet?
I think the spending on AI probably runs ahead of, it does run ahead of the revenue right now. There's no question about that. But the rate of improvement of AI is faster than any technology I've ever seen by far. And it's, like for example, the Turing test used to be a thing. Now, your basic open source random LLM running on a friggin' Raspberry Pi probably could, beat the Turing test. So there's, I think actually, like the good future of AI is one of immense prosperity, where there is an age of abundance, no shortage of goods and services. Everyone can have whatever they want, except for things we artificially define to be scarce, like some special artwork. But anything that is a manufactured good or provided service will, I think, with the advent of AI plus robotics, that the cost of goods and services will trend to zero. Like, I'm not saying it'll be actually zero, but it'll be, everyone will be able to have anything they want. Mm-hmm. That's the good future. Of course, and in my view, that's probably 80% likely. So look on the bright side. Only 20%. 20% probably of annihilation. It's nothing.
Is the 20% like? What does that look like?
I don't know, man. Frankly, I do have to go engage in some degree of deliberate suspension of disbelief with respect to AI in order to sleep well, and even then, because I think the actual issue, the most likely issue, is like, well, how do we find meaning in a world where AI can do everything we can do, but better? That is perhaps the bigger challenge. Although, at this point, I know more and more people who are retired, and they seem to enjoy that life. So, but I think that maybe there'll be some crisis of meaning, because the computer can do everything you can do, but better. So maybe that'll be a challenge. But really, you need the sort of end effectors. You need the autonomous cars, and you need the sort of humanoid robots or general purpose robots. But once you have general purpose humanoid robots and autonomous vehicles, you can build anything. And there's, I think that there's no actual limit to the size of the economy. There's obviously, the mass of Earth, like that will be one limit. But the economy is really just the average productivity per person times number of people. That's the economy. And if you've got humanoid robots that can do, where there's no real limit on the number of humanoid robots, and they can operate very intelligently, then there's no actual limit to the economy. There's no meaningful limit to the economy.
You guys just turned on Colossus, which is like the largest private compute cluster, I guess, of GPUs anywhere. Is that right?
It's the most powerful supercomputer of any kind.
Which sort of speaks to what David said and kind of what Peter said, which is a lot of the kind of economic value so far of AI has entirely gone to NVIDIA. But there are people with alternatives, and you're actually one with an alternative. Now, you have a very specific case because Dojo is really about images and large images, huge video. So
the Tesla problem is different from the the sort of LLM problem. the nature of the intelligence is actually, and what matters in the AI is different to the point you just made, which is that in Tesla's case, the context length is very long. So you've got gigabytes of context.
Gigabyte context windows, yeah.
Yeah, you've got, sort of
I was just bringing it up.
kind of billions of tokens of context,
Right.
nutty amount of context, because you've got seven cameras, and if you've got several, let's say you've got a minute of several high def cameras, then that's gigabytes. So you need to compress. So the Tesla problem is you've got to compress a gigantic context into the pixels that actually matter, and condense that over a time. So you've got to, in both the time dimension, the space dimension, you've got to compress the pixels in space and the pixels over in time, and then have that inference done on a tiny computer, relatively speaking, a small, like a few hundred watts. It's a Tesla-designed AI inference computer, which is, by the way, still the best. There isn't a better thing we could buy from suppliers. So the Tesla-designed AI inference computer that's in the cars is better than anything we could buy from any supplier. Just by the way, that's kind of a.
Oh, by the way,
the Tesla AI chip team is extremely good.
Well, you guys, in the design, there was a technical paper and there was a deck that somebody on your team from Tesla published, and it was stunning to me. You designed your own transport control layer over Ethernet. You were like, Ethernet's not good enough for us.
Yeah.
So you had this TT-CoE or something, and you're like, we're just going to reinvent Ethernet and string these chips. It's pretty incredible stuff that's happening over there.
Yeah. No, the team, the Tesla chip design team is extremely good.
But is there a world where, for example, other people over time that need, some sort of video use case or image use case could theoretically, you'd say, why not? I have some extra cycles over here, so it should kind of make you a competitor of NVIDIA. It's not intentionally per se, but.
Yeah, I mean, there's training and inference, and we do have those two projects at Tesla. We've got Dojo, which is the training computer, and then our inference chip, which is in every car, inference computer. So, and Dojo, we've only had Dojo 1. Dojo 2 is, we should have Dojo 2 in volume towards the end of next year. And that will be, we think, sort of comparable to sort of a B200 type system, a training system. So I guess there's some potential for that to be used as a service. Dojo is just kind of like, I mean, I guess I have some improved confidence in Dojo, but I think we won't really know how good Dojo is until probably version 3. It usually takes 3 major iterations on a technology for it to be excellent, and we'll only have the 2nd major iteration next year. The 3rd iteration, I don't know, maybe late, 26 or something like that.
How's the Optimus project going? I remember when we talked last, and you said this publicly, that it's in doing some light testing inside the factory. So it's actually being useful. What's the build of materials, and when, for something like that at scale? So when you start making it like you're making the Model 3 now, and there's 1 million of them coming off the factory line, what would they cost? $20,000, $30,000, $40,000, you think?
Yeah, I've discovered that really anything made in sufficient volume will asymptotically approach the cost of its materials. So now some things are constrained by the cost of intellectual property and paying for patents and stuff. So a lot of what's in a chip is paying royalties and depreciation of the chip fab. So, but the actual marginal cost of the chips is very low. So Optimus, it obviously is a humanoid robot. It weighs much less and is much smaller than a car. So you could expect that in high volume, and I'd say that you also probably need three production versions of Optimus. So you need to refine the design at least three major times, and then you need to scale production to sort of the million unit plus per year level. And I think at that point, the cost, the labor and materials on Optimus is probably not much more than $10,000.
Yeah, and that's a decade-long journey, maybe?
Basically, think of it like the Optimus will cost less than a small car.
Right.
So at scale volume with three major iterations of technology, and so if a small car, costs $25,000, it's probably like $20,000 for an Optimus, for a humanoid robot that can be your buddy, like a combination of R2-D2 and C-3PO, but better.
Yeah, I mean...
and honestly, I think people are going to get really attached to their humanoid robot because, like you look at you watch Star Wars and it's like R2-D2 and C-3PO, I love those guys.
Yeah.
They're awesome. And their personality and all R2 could do is just beep at you. Right? and couldn't speak English. And need C-3PO to translate the beeps,
So you're in year 2 of that. If you did 2 or 3 years per iteration or something, it's a decade-long journey for this to hit some sort of scale. And
I would say major iterations are less than 2 years, so
okay.
It's probably on the order of 5 years.
Yeah.
Maybe 6 to get to 1 million units a year.
And at that price point, everybody can afford one on planet Earth. It's going to be that 1-to-1, 2-to-1. What do you think ultimately, if we're sitting here in 30 years, the number of robots on the planet versus humans?
Yeah, I think the number of robots will vastly exceed the number of humans.
Vastly, yeah.
Vastly exceed. You have to say, who would not want their robot buddy? Everyone wants a robot buddy.
Totally.
It's just like, especially if it can, it can take care of take your dog for a walk. It could, mow the lawn. It could watch your kids. It could, it could teach your kids. It could.
We could also send it to Mars.
Yeah, absolutely.
We could send a lot of robots to Mars to do the work needed to make it a colonized planet for humans.
And Mars is already the robot planet. There's like a whole bunch of robots, like rovers and
only robots.
Helicopter. Yeah, it's only robots. Yeah. I think the sort of useful humanoid robot opportunity is the single biggest opportunity ever. Because if you assume that, I think the ratio of humanoid robots to humans is going to be at least 2-to-1, maybe 3-to-1. Because everybody will want one, and then there'll be a bunch of robots that you don't see that are making goods and services.
And you think it's one generalized robot that then learns how to do different tasks, or?
Yeah.
Hey,
we are a generalized.
Yeah, we're a generalized non-robot.
We're just made of meat.
Yeah, exactly. We're a meat bot, a generalized meat bot.
Yeah, I'm operating my meat puppet, we are actually. And by the way, it turns out, as we're designing Optimus, we sort of learn more and more about why humans are shaped the way they're shaped, and why we have 5 fingers and why your little finger is smaller than your index finger. Obviously why you have opposable thumbs, but also why, for example, the muscles, the major muscles that operate your hand are actually in your forearm, and your fingers are primarily operated the muscles that actuate your fingers are located. The vast majority of your finger strength is actually coming from your forearm, and your fingers are being operated by tendons, little strings. And so the current version of the Optimus hand has the actuators in the hand and has only 11 degrees of freedom. So it doesn't have all the degrees of freedom of human hand, which has, depending on how you count it, roughly 25 degrees of freedom. Right. And it's also not strong enough in certain ways because the actuators have to fit in the hand. So the next generation Optimus hand, which we have in prototype form, the actuators have moved to the forearm, just like a human, and they operate the fingers through cables, just like a human hand. And then the next generation hand has 22 degrees of freedom, which we think is enough to do almost anything that a human can do.